This is an example of the combined gas law. The combined gas law is P1 times V1 over T1 equals P2 times V2 over T2. And it's called that because if you need, say, Boyle's law deals with pressure and volume. So you cover up temperatures, cover up the T1s and T2, and you get what Boyle's law would be. If you need Gay-Lussac's, that doesn't have volume, so cover up the volumes, and there's Gay-Lussac's. If you need Charles, cover up the pressures, and there's Charles. So this is just a combination of all three. This is real handy, but you don't always have all that information, and that's why we don't always use it. But if all three variables are changing, then you kind of have to use it. So, I'm just going to start with let statements because it helps me to see if anything needs converted. But you need to at least show me how the numbers plug into the equation and your answer. So the let statements are optional. Okay, so this says a balloon has a volume of, so that even tells me that's a volume. So I'm going to put 106.0 liters. When the temperature is 45, so 45 degrees Celsius is here, and the pressure is 740, and that's in mmHg. What will its volume be? So that's X at 20 degrees and 780 mmHg. So the first thing you need to do is make sure that temperatures are in kelvins and all the other variables match each other. So add 273 to your temperature. I think that's 318. And 293. And then this pressure is in mmHg, this pressure is in mmHg. So we're good there. And then the volume is in liters. So as long as we label our second volume liters, we're good to go. Then you just fill it into the equation. So P1 is 740 times V1 is 106 over T1 is 318 equals P2 is 780, V2 is X, over T2 is 293. And then we're going to cross multiply. So all these times each other equal to all these times each other. So 740. And all this part here is optional as well. The part up here that I just did, you need to show me in your answer. But I'm just showing you because some people won't remember how to do that because it's been a while. And then you divide both sides by whichever one has the X by it. So you end up with X equals significant digits. Now, I did this on purpose so that you would know. Don't go over to here for significant digits because I dropped zeros, and that happens without thinking a lot of times. So always go back up to the typed part for your significant digits. Look at only numbers we've used, but we've used all those. So we have 4, 3, 4, 3, 4. So we need 3. So I'm getting 92.7 liters. And that is how you do a combined gas law problem.